did not expect that. Okay, there we go. All right, so we're going to try and prove that if two opposite sides of a quadrilateral are equal and parallel, then the quadrilateral is a parallelogram. So we can only assume the properties of a quadrilateral in this case because we are trying to prove that this is a parallelogram. Okay, so there are a couple of ways that we can do this. Okay, first we're going to construct. So if you were here with us on Monday, we're going to construct a line. Oh, and I haven't named it yet. Hello, Bukanyo. Okay. A, B, C, D. I'm going to say construct line A, C. Okay. And then we're going to draw a line from here today. Okay. Okay, cool. All right, so if we draw this like that, we're going to remember that they've given us certain properties over here. They're saying that if two opposite sides of a quadrilateral are equal, so they're saying that if this side and this side are equal, and two opposite sides, and that side are equal, and they're also parallel, so that one and that one are parallel, and that one and that one are parallel, then we should we're required to prove that this is a parallelogram given the other properties that we know of a parallelogram. All right, so in this case, we know that we're trying to prove using sides and angles. So I know that I can't be using a similarity proof, because if it was a similarity proof, I'd only be able to use angle, angle, angle. So in this case, because I have sides and I have angles, I'm going to use a congruency proof. All right, so does anybody want to map out the triangles for me? Hello, Palesa. Okay, I have to say proof. In triangle, anybody want to give me the first set of triangles that we're going to use? You can just pick one. In triangle, what? Okay, thank you, Kiratilo. Kiratilo says in triangle A, B, C. And guys, we need to take note that we started at a big corner, an obtuse corner, and we went down past the short side and then past the long side. So we would say in triangle A, B, C, and triangle. Now, if we have to map out the other triangle, in what order do we then need to go? We need to go from an obtuse corner, so we would have to start at C. And then from C, where would we go, guys? Correct. Yes, Karatilo. Good. We'd go from C to D. So we're going from an obtuse corner, and then we're going up the short side, and then past the long side, and then down. So our triangle should read triangle CDA. Those are the two triangles that we've been given. Okay. Then we know if we're proving congruence, we need 3 reasons. Oh, and I erased the whole thing. No, okay, I'm going to leave it like that. We need 3 reasons. 1, 2, 3 to prove congruence. Does anybody want to give us one of them? Let's look at the triangles and what the information that we've been given. Just want to see if I can get it from that side. Good. All right. So what do these lines tell me? These lines here and there. What are those lines actually telling me?
Is it not that the sides are equal?
Correct. It's that the sides are equal, right? The lines, the 2 lines, or the 1 line, that tells us that the 2 sides are equal. And the arrows, what do the arrows tell me?
That they're parallel.
Correct, that they're parallel. So the 2 lines tell me that they are equal, and the arrows tell me that they are parallel. And then we know that if we see parallel lines, then we need to think of fun angles. So you're not wrong, Keratilo, you're absolutely correct. Okay, so in this case, the lines tell us that they're equal. So if I look at my parallelogram, or my 2 triangles, that tells me that AB is equal to CD. AB is equal to CD. And we can say that this is the properties of a parallelogram. Properties of a poly. Okay. Now, can we see anything else? Can anybody tell me any other two sides that are equal? Anyone? Remember, look at the lines. Correct, Geratilo, yes, 100%. Okay, so we can tell from here, because these two have lines, those two also have lines in this direction. So that means that AD is equal to BC. And that is also the properties of a parallelogram. Okay, then we need to think of the last thing that we can do. Remember, we've got a side, and then we're going to notice something. Do we see that they share a side? Yes, are we aware that they share a side? They share the side AC. They both have AC. So that I can make my third reason there. Just give me a second. I can make my third reason. AC is common. Okay. And that is also another side. Okay, now that I've got my three reasons, then I can say, therefore, triangle ABC is congruent to triangle CDA. Okay, that then tells me that everything else about this is also going to be equal, right? Because if the two triangles are congruent, then the angles are all the same. The sides are all the same. Everything about them is exactly the same, right? So we can then use that to look at the alternate angles. Okay, we can then look at the angles and see which angles equal each other in order for us to prove that this is a parallelogram. Okay, so I can then say, therefore, angle A is equal to angle C. I can say angle A is equal to angle C, and the reason for that is congruent triangles. The parallelogram is labeled ABCD. Do you see it? I'll just highlight them in purple here. A, B, C, D. There we go. All right. So that tells me that angle A is equal to angle C, and that's because of congruent angles. Oh, yes, we should technically number them. Yes, we can do that. 1, 2. We can. So I can say that A1 is equal to C1. A1 is equal to C1 because of congruent triangles. I can then also say that angle B is equal to angle D, also because of congruent triangles. B is equal to D. Congruent triangles. And then I can look at the other one. Angle C is equal to angle A. In this case, it's going to be angle A2 is equal to angle C2. A2 is equal to C2, and that's also because of congruent triangles. Okay, now, if all the angles that align are equal to each other, that then proves, therefore, that AD is parallel to BC, and AB is, now I'm saying equal to, not equal to, guys, parallel. Parallel, and AB is parallel to CD, not equal. All right, so in this case, we've proved that all the opposite sides are equal to each other, and we've proved that the opposite angles are equal to each other, which proves that the two lines are parallel. Okay, and this is kind of a long proof. I'm going the long way about it, but we all need to know how to do this. Of the three theorems that we have, there's a chance that one of them might come out in the exam. maybe at the end of the year, the one that you guys write for the government. So these proofs do come out, maybe one. Okay, so we just need to be aware of that. So today we're going to be using the properties of parallelograms in order to understand or in order to answer certain questions. Now, I just want us to note, guys, when we are answering questions and we say, let's say, for instance, we say here that dm is equal to EL, and then we have to give a reason. We can't just say properties of a parallelogram. Okay, we can't just say properties of POM. That's not good enough. Okay, yes, it is. We understand that in a parallelogram, if they tell you that it's a parallelogram, then the two sides opposite each other are equal. It is a property, yes, but you must state the actual property. You can't just say properties of a POM. You need to say opposite sides of a POM are equal. You need to put that whole thing in there so that you show that you understand which property you're using. You're not just saying it's one of them. No, you must be very specific on which one you're using. All right, can I get a thumbs up? Is ma'am making sense there? Okay, so if we say that the angles are equal, we need to use the property about the angles being equal. We can't just say properties of a parallelogram. That's not good enough. Okay, cool stuff. All right, let's start with the question that we've been given over here. So it says here, DELM is a parallelogram. Do you see how lovely they're being? They're telling us that this is a parallelogram. So we can use all the properties of a parallelogram that we know. So we now start thinking about all of those. I know in a parallelogram that opposite sides are equal. Does somebody want to give me another one? Opposite sides are equal. What else do we know about parallelograms?
Opposite sides are parallel.
Opposite sides are parallel. Good. That's a good one. Opposite sides are parallel. Right. Correct. Yes. Yes, Sally. Absolutely. We also know, I'm just going to make some space over here, that opposite angles are equal. Correct. Opposite angles are equal. So we know all of this information. Okay. I just don't want to write parallel. It looks so long there. Let's just make the strokes for parallel. So we know that we can use all of these properties of parallelograms when answering the questions that they're asking us for here. Okay. So we're going to use these properties, and then they tell us that DM is equal to 50. We're going to just say 50 units. And angle L is equal to 150 degrees. Then it says, calculate the length of EL and the size of angles D, E, and M. Okay, so let's start with the length of EL, because the length of EL is going to be the easy one to answer, right? EL is this part over here. Okay, so we can just start by saying EL is equal to what? Who can tell me? EL is equal to? DM,
50.
absolutely. DM, which is equal to 50. So we're going to say EL equals DM equals 50. Okay, and our reason, not properties of a POM, we're going to say opposite sides of a POM are equal. Opposite sides of POM equal. Okay, we need to say that whole statement. Okay, lovely. Now let's talk about angle D. Okay, we figured out the length of EL. That's great. Now they want us to find the size of angle D. Who can tell me how big is angle D? Angle D is equal to what? Good. Yo, Sally, you're on fire today. Good. Angle D is equal to angle L, which is equal to 150 degrees. And which property did we use? We have to use that opposite angles of a parallelogram are equal. So we can say opposite angles of POM equal. Okay. Then we need to find the angle E. Okay. We need to find E. How can we use the properties that we know to find E? Okay. I'll give you guys a hint. We need to use the fact that the opposite sides are parallel. Okay. And ma'am will remind you again. Parallel lines, what do we need to think of? Parallel lines? Fun, good. Parallel lines, fun angles. Let's try and use the fun angles to figure out how to answer that question. Ah, there we go, Tseho, good. Right, we can use co-interior angles, right? So we can use that. We can use the U, and we know that co-interior angles need to equal 180. So I can say angle L plus angle E is equal to 180 degrees. And that is because of co-interior angles. And I need to state my parallel line. So I need to say DE is parallel to ML. Okay, therefore, angle E is equal to 30 degrees. Right, and now I know what angle E is. I've been able to calculate it. I've now figured out what angle E is. I now need to figure out what angle M is. Who can tell me what is angle M? How much is angle M? Angle M is equal to, good. Yes, absolutely. It's equal to 30 degrees, right? And the property we can use again is the opposite angles of a palm are equal. There we go. All right. So we need to be able to use the properties, but because we can't just say properties of a palm, remember you're not even telling us what kind of palm. You can't just say that, because what if the parallelogram is a rectangle or a square? We need to be very, very specific about which properties we're using. Okay. All right. Can I give you guys one to try on your own? Yes? Yes. Okay, lovely. Here's the next one. Here's the next one. It says DELM is a parallelogram. Hooray. They tell us the information we need. Right. So we need to think of all the properties of a parallelogram. Just name them. You know them already. Right. Now it says calculate the value of X and hence the sizes of the interior angles. Okay. So I want you guys to go ahead and use the properties of a parallelogram to figure out what X is equal to. Oh, X and 2X, guys. I'll give you some time. When you're ready, pop your favorite emoji in the chat. Okay, lovely. I see people are finishing. We can get into it. Okay. So if we think about the properties that we're going to use here, and it's okay, guys, if you aren't finished, we can catch up together. All right. So we know that we have parallel lines because this is a parallelogram, right? We're going to have parallel lines. So I know that I can use fun angles. So I'm going to use the co-interior angles parallel lines. Oh, that sounded very weird. So I have to say 2x plus x is equal to 180 degrees. Then I have to say co-interior angles, and then I have to give the parallel line. So I have to go dm is parallel to EL. Okay, then I know 2x plus x is equal to 3x is equal to 180. Therefore, x is equal to 60 degrees. Now, the question over here said, calculate the value of x and hence the sizes of the interior angles. So it wouldn't just be good enough for you to say x is equal to 60. You would then also have to say that 2x is equal to 120. And that's how you would get the full mark. Okay, so don't forget to add that last part also, because they want you to also give the sizes of the interior angles. So we know that the interior angles are 60 and 120. All right, how did we do, guys? Let's get 1 mark for that, 1 mark for that, and 1 mark for that. Out of 3, how did we do? Three out of 3, I like it. Good stuff. Okay. Awesome, guys, awesome. Okay, cool. We just divide by 3 on both sides because 3x is equal to 180. Divide by 3, divide by 3. Okay, 180 divided by 3 will give us 60 degrees. Okay. Oh, okay. Sorry, I know that last part, that 2x is equal to will get you. Yeah? Yeah, so we just need to remember that in the future. Okay, guys, let's look at something a little bit different. Okay. And I know that we have definitely forgotten the properties of a trapezium because I also, when I was putting this together, I also had to remind myself, what are the properties of a trapezium? Okay, it says here, in trapezium A, B, C, D, AD is parallel to BC, which is lovely. We have parallel lines, so we need to think of fun angles. Okay, we already know we're going to go there somewhere with fun angles. Then they tell us angle A is equal to angle D, which is equal to 70 degrees. And then they say that EC is equal to DC. Okay, let's give me 1 second. Yeah, sorry. So yes, so we know that EC is equal to DC. So we want to prove that ABCE is a parallelogram. So we need to remember that this time we don't have the properties of a parallelogram, We are trying to prove that this is a parallelogram. Okay, so we then have to either prove that opposite sides are equal. We either have to prove that opposite angles are equal, or we would then have to prove that the diagonals bisect. Okay, and the diagonals bisect one is when you draw a line from there to there, and then you draw a line from there to there. Remember we did that one on Monday, where if this part over here, we'll call that F, if it cuts it up into 2 equal parts there and an equal part there, then that proves that they are equidistant. So they're the same distance apart on each side, which makes the triangles inside congruent. So that's what the diagonals bisect one means. But in this case, we don't have that much information, right? So if we look at the drawing that they've given us over here, have they given us any sides in this drawing? Any sides? Any value of sides?
DC, side DC is equal to side EC.
Okay, yes, but okay, so but that doesn't really tell us very much about the length of each of the sides, right? Do you agree? So I can't, unless I draw unless I draw congruent triangles and I try and figure that out, which is going to be a nightmare, that won't help me in this case. Okay, what I mean is, did they put a 50 here and a 50 there and 100 there? Did they help us out in that kind of way? No, they haven't helped us in that way at all. Okay, what they've given us is angles. They've given us 2 angles. So of these 3, of the 3 that we would need to prove a parallelogram, it would be easiest for us to prove that one, that the opposite angles are equal. I'm sorry for all the confusion. Do you guys understand what ma'am is saying? Okay, I feel like I flip-flopped a little bit up and down with that. If they haven't given us like like this side is equal to this side and this side is equal to 20 or anything like that, it's going to be a lot easier for us to use the angles to prove that it's a parallelogram. Okay. Or maybe I'm speaking in circles. I hope not. Okay. All right. Let's start by looking at opposite angles being equal, right? I'm going to look at this shape over here. Do we all see that we've been given a triangle over here? Right. And I know that if I have a triangle that has these 2 things over there, it's called a certain type of triangle. Who knows what kind of triangle it is?
Isosceles.
Absolutely. It's an isosceles triangle. Right. So we can say triangle EDC is isosceles. Right. So I know that if these 2 triangles are isosceles, then what does that tell me about the base angles?
The base angles are equal.
Right. Yes. Thank you, Sadie. Yes. Yes, Seho, you're absolutely correct. Then we can say angle E, or angle E2 is then angle equal to angle D, which is equal to 70 degrees. And remember, we can't just say isosceles triangle, or they keep changing it. Guys, I don't know. Okay, but the last time I was teaching this, we were not allowed to say isosceles triangle. You have to say equal sides, opposite angles. There we go. Equal sides, opposite angles. That's the one. Okay, equal sides, opposite angles. That means that if there are 2 equal sides, then the angles opposite each other are also equal. Okay. All right, so then if I know what E2 is equal to, can I then calculate what E1 is equal to? Yes, I can, right? We know what we can use there. Right? We can use just angles on a straight line, nothing too big, right? Then we can just say E1 plus E2 is equal to 180 degrees, right? Angles on a straight line. Right? Now, I know that E2 is equal to 70 degrees. Oh, I wrote equals instead of plus. Sorry, guys. Plus. Okay, I know what E2 is equal to. E2 is equal to 70. So I can say that E1 is equal to 180 minus 70 degrees, which is equal to 130 degrees. Okay. So we now know that E1 is equal to 130 degrees. Okay, so if we know that this is equal to 130 degrees, we still have to use our fun angles, guys. Is it 110? Oh, it's 110. Sorry, guys. Oh, yo. My maths went out the window there. Yes, 110 degrees. I was testing you guys. You passed. You passed. Thank you. 110 degrees. Okay, and I was so sure, guys. I was so sure. 110 degrees. Okay, so if this is 110 degrees, if we use our fun angles, can we figure out what C1 is equal to? Are we able to figure that out? Yes. Okay, what are we going to use? Good, Sally, absolutely. We're going to use co-interior angles. Remember, for alternate angles, we would need an N or a Z, and we don't have one. Okay, in this case, we do have a U for co-interior angles. We have a U, and that is co-interior angles. Okay, if it was alternate, I would need that, and I don't have that middle part. Okay, so we're going to use the U. So in this case, we can then say E1 plus C1 is equal to 180 degrees, and we can say co-interior angles. Co-interior angles, and I need to name my parallel lines. So AE is parallel to BC. Okay. Then we can work out what C1 is equal to. C1 is equal to 180 minus 110 degrees. Therefore, C1 is equal to 70 degrees. Right. Now we know that C1 is equal to 70 degrees. What do we notice? Does anybody see it? What do I notice? Opposite angles. Good, Sally. Yo, Sally, you're killing it today, my darling. Well done. Good. We can see that the opposite angles are equal. Right. We can say now that angle A is equal to angle C1, which is equal to 70 degrees. Right? Then we can say, therefore, ABCE is a palm. And our reason for that is that our opposite angles are equal. Okay. All right, that was a bit of a difficult one, but it does come up. Okay, shall we try another one together? Do you want to try one by yourselves? I can do another one with you guys because this was a bit tricky. Okay, let's do one together. Okay, here we go. Proofs using properties. All right. So we're going to use two triangles that are isosceles to prove that ABCD is a parallelogram, right? So we need to then think of properties of two things. First, we need to think of the properties of an isosceles triangle, right? Because that's going to help us. We must know what it is we know about an isosceles triangle. And then we also need to know the properties of a parallelogram in order for us to know which ones we want to use, right? Which properties we want to use. Okay, and this one is going to be quite a bit of a long one, so I want you guys to stick with me with this one. All right. Okay, so in this triangle over here, they tell us in the write-up over here, they tell us that angle C is equal to 75 degrees. So that angle over there, 75 degrees. Angle ADB, let's go look for it. ADB is equal to 30 degrees. Okay, then they say prove that ABCD is a parallelogram. Okay, so if we know that, I think Oko's got it for me. Oko, what do you think we're going to do here?
No, I just wanted to ask. Sorry, ma'am, how do we know like which triangle to? Okay, wait. No, sorry, I got the answer to my question just by looking at the thing.
Did you answer your own question?
Yeah.
Is it coming to you now? I hope you know what we're actually getting at. Okay, and I'm glad that she's figured it out before we even got there. Okay. So we just need to make sure that, okay, we're looking at it properly and the information that we've been given. All right, so if we know that this side over here is 30 degrees, right? We know that this angle and that one must be what?
$60.
Oh, is it going to be 60? Remember, this is a triangle, my darling. Okay, maybe let's start in the other triangle. Okay, if we know that this is an isosceles triangle, that's 75, what should that be? how much should D1 be? Correct, Sally, absolutely. Right, D1 should be equal to 75 degrees because those are the base angles of my isosceles triangle. So this should be 75 degrees, right? So I can say angle C is equal to angle D1, right? Which is equal to 75 degrees. Okay, and then I have to say opposite angles equal sides. Okay. Opposite angles equal sides. Okay. That then tells me that therefore B1 is equal to, can I figure out what B1 is? Yes, I can. Can you calculate B1 for me, please? Correct, Sally. Absolutely. B1 is equal to 30 degrees. Good. So I know that B1 is going to be 180 minus 75 degrees minus 75 degrees, right? Which is then going to tell me that B1 is equal to 30 degrees, right? So we now know that B1 is equal to 30 degrees, right? If we look in, okay, in fact, I should have said in triangle BCD. We were working in triangle BCD. Okay. Now I know that in this triangle over here, in triangle A, oh no, I can't start at A. I started there, B, C, D. So I need to start DAB. Okay, now I have to say in triangle DAB. Okay, this is the angle at the top. I know that these two base angles must equal what? Correct. They must also equal 75. Correct. They must also equal 75. So I can write it out. I can say angle A plus angle B2 is equal to 180 minus 30 degrees. Right. And then I can say that angle A is equal to angle B2. Right? That is opposite sides equal angles. Okay, opposite sides equal angles. So I can then say I've got 2A. So I've got 2A, because if A is equal to B, that means that B, I can also replace B2 with A. Right, so that tells me 2A is equal to 150, not 180. 150 degrees, and then I can divide both sides by 2. Divide by 2, divide by 2. Therefore, angle A is equal to angle B2, which is both also equal to 75 degrees. Okay, I know that was a lot. Are we all okay with what ma'am's done here? Are we good? Is everybody understanding what ma'am has done? Okay, cool. Right, because if these are the base angles of my triangle, of my isosceles triangle, they've told me it's isosceles, then these two angles must be equal to each other, which means if I have this one, whatever's left over is just going to be split in two for those sides. Okay. Guys, I don't want to leave you guys behind. Hey, if you're stuck and you're not sure and you have a question, please ask a question. I'm happy to go back as well. Okay. All right. Okay, so I've now just proven that. Okay, Desmarie, which part am I explaining again? Okay, are you okay with how ma'am got to the answers in this triangle? Are you okay with that? Yes? Okay, cool. So I'm guessing it's this last part here, this one. Yes? Is that the one that's a little... Okay, all right, let's run it back. Let's do this. So we know that triangle DBA is an isosceles triangle, right? They've told us that's it's an isosceles triangle. And there are two things we know about an isosceles triangle. We know that these two sides, these two long sides are equal to each other. And what do we know about these two base angles? That they are also equal to each other, right? So if I then name this side X. I'm going to name this angle over here X, right? I'm going to name B2X. If B2 is equal to X, and these are the base angles of an isosceles triangle, what is A going to be equal to? What is angle A going to be equal to? Are we all in agreement? It's going to be X. Yes? Because if these two angles are equal to each other, if that one is named X, then this one must also be named X. Give me a thumbs up, guys. Is ma'am making sense? Are we all good? Okay, cool. All right, so because the angles are both equal to each other, we can call both of them X, right? So what I'm going to do now is I'm going to add up all the interior angles of my triangle. And I know that the interior angles of a triangle must equal 180 degrees, right? So if I set up my equation, I'm going to say, okay, in triangle DAB, right, I'm going to say X plus 30 degrees is equal to 180 degrees, the interior angles of a triangle. Okay, now if we're looking here, can you guys solve for X for me? If we solve for X, what do we get? We're going to get 2X is equal to 180 degrees minus 30. Therefore, 2X is equal to 150. There we go. You see, then we're going to get that X is equal to 75 degrees. Okay. Yes, it is, Karatilo. It's 75 degrees. Right. So that tells me that both of these base angles over here are 75 degrees and 75 degrees. Okay. So all I'm saying is that I took a shortcut. Okay, but I essentially did the same thing. So what I did instead, I was like, because I know that this thing is equal to that thing, I have two of them. So I just need to take 180 minus 30 and divide by 2. So I just took a shortcut, okay, which granted, I probably shouldn't have done. I should have gone the long way around just so we can get it. But are we okay with the idea of what ma'am has done here? Yes? Good. I'm glad, Desmarie. Okay, I don't want to leave you behind. Wonderful. Okay, so we've got these two things. I'm going to leave both of them up. Right, but now I know that I need to prove properties of a parallelogram. I need to prove that this is a parallelogram, right? What I can do is I can look at the fact that they've given me two triangles. And if I wanted to prove the properties of a parallelogram, what can I do with two triangles? What can I prove with two triangles? Do we remember? If I'm given two triangles, I can prove what or what? There's two of them.
Is it not congruency and similarity?
Absolutely good. I can either prove congruency or similarity, right? But if I prove similarity, the only thing that is going to tell me is that the angles are equal. But we already know that. We can tell it, right? But if I want to prove that something is a parallelogram, I'm going to need sides. So I can't use similarity. I'm going to have to use congruence in order to do this. Okay. So I can use the two congruent triangles, and I'm going to map them out for ourselves. We're not going to use the triangles that they've given us over there. We're going to map our own ones out. Okay, so I'm going to give you guys the first one. Right, I'm going to say in triangle, I'm going to say BAD. Okay, in triangle BAD and triangle, I want you guys to give me the other triangle. What is the other triangle going to be? Check where I started. I started at B. I went past the short side. Try again, Karatile. Remember, I started at a big angle. Do you see how that's a big angle? I went from a big angle down the short side. So in my other triangle, I'm going to have to start at the big angle. Which one is the big angle? Okay, you're correct. We're going to start at D. But if we go from D to B, do you see how we're going down the middle? We shouldn't be going down the middle, hey? So we should go from D to, there we go, DC. We need to go from the big angle, past the short side, and then past the long side. Okay, so it will be in triangle BAD and triangle DCB. Okay, now remember we're proving congruence, so we must use angles and sides. Okay, who has any of the angles or the sides for me? Okay, can I start us off? Let me start us off with something really nice and easy. Okay, angle B1 is equal to angle D2 is equal to 30 degrees. And luckily for us, we calculated it above, so we can say proved above. We did that. We proved it above. Right. What else can I say? That's my first one, and my first one is an angle. Remember, we're proving, guys, so we need three things. 1, 2, 3. Okay, ma'am's given you one. Can we see another one? Absolutely, Palesa, yes. BD is common. Right, BD is common in both of them. BD is common. Right, and we don't really need a reason for that one. Let's think of one more. Good. So we've got that. BD is common. What else do we know? That's a side, by the way. Angle C is equal to angle A. Absolutely. Angle C is equal to angle A. And we can say calculated above. Okay. And I think I may have just had us go the long way around instead of just actually seeing it. But we can finish. All right. So we know that we've got our three. Therefore, triangle BAD is congruent to triangle DCB. Right? And that is because of angle side angle. Okay, we actually got it right this time. Angle side angle. Angle side angle. All right. That then tells me, therefore, that tells me that side BA is equal to, therefore, side BA is equal to which side? DC, correct. BA is equal to DC. And side AD is equal to side BC, right, or CB, correct. AD is equal to CB, right? And there we've proven that the opposite sides of our parallelogram are equal, right? So I can say, therefore, ABCD is a palm. And then I can say opposite sides equal. There we go. Okay, I can even take it further and say angle B is equal to angle D1, or B2 is equal to angle D1, angle C is equal to angle A, and then we can say because of opposite angles being equal, of a palm being equal. Okay, so you can do either of those. All right, so it just takes a little bit of thinking outside the box, guys. I have one more. I'm gonna ask you guys if you want to go and try it. You can go ahead and try it, but we can tackle it again next week, Monday. But I think we're starting something new next week, Monday.